Right, find the domain of the rational function. Well, first of all, remember a rational function, or even a rational expression like in question 4. It's just, that can I put it, it's just something over something else. It kind of looks like a fraction. You've got, but it's not just, I suppose 1/2 is a rational expression. So something over something else. Now then, finding the domain of the rational function. Well, domains are all about, what values of x, or whatever letters in the question, you can use in this function or expression. What are you allowed to use? Now, think about this. The only restriction you have is you can't divide by 0. Okay, so remember that with, sorry, itchy nose. You cannot divide by 0. So, if I just think about, what numbers I can put into this rational function. Well, if I put a 1 in, what am I going to get out of it? If I put a 2 in, what will I get out of it? When I put 2 in for x. But how about when I put a 3 in for x? Have you seen this? Look at the bottom here. Let me just make my pen a little bit bigger. Okay, so look at this here. If I put x equals 3 into this, I'm going to get a 0 on the bottom, aren't I? Now, I can't have that. In other words, I can put whatever I want into that kind of expression there, that function, and I'll get an answer out. But if I put 3 in, I'm going to get a 0 on the bottom, and remember that's undefined. So really, all we're saying is just x cannot be 3. It can be anything else. Okay? So I think it's all about how to write the answer really for this. And I'll just show on this next little sheet I've got. So a little diagram as well. So really, this, again, my pen's too big here, so let me just go back. Okay. Right, so this is how the kind of questions you see in the quiz, the kind of answer looks like, and how the case they want you to write the answer. But there are different ways of writing the answer. I mean, basically, here's that look. This bit here, this is the x cannot be 3, but this is written in the fancy parentheses, x's, such that x is a real number, and x cannot be 3. Okay? But really, that's the important bit right there that I've double underlined. Okay, x cannot be 3. Now, if you're thinking of interval notation, if you go back to the absolute inequality videos, remember when we had absolutes greater than this, and it only allowed values kind of from here to here, or in between, all right, here to here. Well, look, this is very similar to that. So if you cannot have 3, so there's the 3, all right, and you can have everything else, then basically we're talking about a negative infinity to positive infinity. That's everything apart from the 3 in the middle there, all right. Well, this is how you kind of draw it. Here's the graph of it. Here's the negative infinity, all right, going as far as the 3, okay. So I can have all these numbers. I can't have the 3, but then I can go beyond there, okay, and I can have all these numbers. So really we're saying we just cannot have 3. And again, interval notation is written like that. Now, whether this is in the book or whether we tested on it, just be aware of this. This is very college algebra there. That's how you would write the interval notation of you can't have 3. All that detail, I think myself, I'd just rather do that there. X cannot be 3. Okay? But have a look at how we want to write the answer. Okay? So remember, that is basically telling me you can't have 3. Let's go back and look at some of the other ones. So if I look at this one, probably need a bigger pen here. I've just got a different resolution on this. Okay, so again, really, we're just looking at the denominator. That's all we're looking at, remember. So what value of z there will make that denominator 0? Well, 4 times 0. Don't think negative z. Some will think that, or 1. No, that'll give you 4 if it's 1. It is. Z cannot be 0. So again, let's go back to that sheet. If we're going to write it like this, all I would put is all that and x, sorry about the size of the pen now, it's just different resolution, cannot be 0 at the end there, okay, because x cannot be 0. And let's just do this last one. Now, if you're unsure about this, remember, we cannot have 0. So really, the way to think about this is, right, if I'm not sure, I am going to set that denominator, just the denominator, equal to 0. I know that's what we can't have, and I'll solve. So I take away 4, cat strangling in the background. So 9x equals negative 4. Good grief. Right, divide by 9. divide by 9, so x equals negative 4/9. No, that's what it can't equal. Okay, so remember that, x cannot be negative 4/9 because that makes it 0. And again, if we're going back to that other sheet, I'll do the big pen this time, all that, and x cannot be negative 4/9. Okay, so just think about how I want it written like this. But, you know, if you're thinking of interval notation, then for this one, I would just have a 0 where the 3 is, you know, negative infinity to 0, then 0 to infinity. So all the numbers apart from 0, hence the parenthesis. Remember, you can't have brackets, that means it would include the 0. So we're not having 0, that's why we always use parentheses, okay? So let's go back. So that's it for those first 4 3. That's domains. It really is what makes the denominator 0, so try and think what that makes, and that's what you can't have.